Hi, Ingo. Welcome back.
Hi, Adam. Thanks for having me again. It's a great honor to be here.
We had a nice intro discussion, so I forgot to look up when you were last time here. I think 1 year.
Yeah, just about that. Yeah, 1 year.
Yeah, and why we are talking here is because something nice happened. You are the master of JProfiler, right? So this is
It's
the
my official title. Yeah.
yeah, your official master of JProfiler is MOJ,
Yeah.
and we got Visual Studio Code integration, which is incredible for me because I use a Visual Studio Code all the time for various reasons. And having a profiler well integrated is a big thing. So maybe because the last podcast was around, I think 1 year ago. Let's see. It was, it was 2 years ago even.
As the
Wait a
time
sec.
flies.
2023, why Kotlin is better than Java. This was by you, I think was the last one. And this was in November 2023.
All right. So yeah, it's like
This is time
one.
flies. So I
More.
thought it was like recently, but it wasn't. And yeah, indeed. This was a long time ago.
Yeah, it also took me some time to follow up on your suggestions. I mean, back then you said, why don't you have the VS Code integration? And of course, like it was at that time already had been clear for a long time that VS Code is like, among the top two editors in a sense that people choose nowadays when they go and start a Java project. And so why don't we have an integration? And that was, of course, a very valid question. It's not like we hadn't looked at it and we hadn't thought about it and hadn't decided that this is an important thing to have. But it is actually very difficult to do this, or it was difficult for us to do this from where we came from. And maybe I can explain a little bit about these IDE integrations.
Maybe first, what I wanted to ask you that you briefly introduce what JProfiler is, because this is why I look up. This is like 1.5 years ago, so not all listeners will remember what it is. And what are the strengths of JProfiler? And then we go ahead because I also have questions regarding the language protocol and Visual Studio Code and what you actually did. So
let's do that. So, well, JProfiler is a general purpose Java profiler. It focuses a lot on high level subsystems. Think like Hibernate, JDBC, Kafka, and stuff like that. Communication mechanisms. So it's not just like the method level profiling where you would see the methods in a call stack or in a hotspot list or a flame graph or whatever you prefer. That, of course, it does all that and has a lot of functionality around that, but it also has these high-level features that enable you to understand what your application is actually doing and group things in a way that you really find out where performance problems occur. And it also deals a lot with memory. We have a heap walker that allows you to find memory leaks and analyze memory usage. And there is also threading and contention, stuff like that. So it goes over all the things that you need for inspecting your runtime characteristics of your application and improve them. Mm-hmm. So that's the product. And one of the things, of course, that's really important is how do you get started? How do you start profiling something? And that must be easy because usually, like you're always in a hurry as a developer, and you want to do this and not read up on how to profile something. So one of the ways is to start it from the IDE. That you have an integration and you just, instead of debugging or running it, you just say profile it. And you don't care about the class path, the main class, and things like that. It should just work like your normal run configurations in the IDE. That's one way. The other way, which is used a lot, is by attaching to something that's already running. That's also a very...
And IDE, you mean IntelliJ, for instance? And
yeah, like IntelliJ, like VS Code, like Eclipse or NetBeans, even if you want to go that far. And that's where the programmer usually starts their code. That's in a development environment, because JProfiler is very much like a development tool. You use that during development. You can use it in production. That's where the attaching comes in, because then you need to, you don't start it from the IDE. It's already running somewhere, and you need to like get in there and do some measurements. And then you have the attaching stuff where you need to like go through SSH or have something in Kubernetes or on Docker. And there's lots of complicated topics on how to actually get to the JVM that you want to profile. And that's what is also one of the core strengths of JProfiler, like dealing with this situation of getting to a profile, a JVM. That's something we work on.
And what I correctly remember is you are also understanding the Java Flight Recorder events, right?
Absolutely. Like Java Flight Recorder is is not like a competitor, really. It's one of our data sources, and we also like aim to be like a complete replacement for mission control. So you don't really need mission control if you have JProfiler, because like you start Flight Recorder from JProfiler with all the information you get. You get all the data in JProfiler's views that are also specialized for Flight Recorder if you do that. So that is one of the things that we use all the time, especially like for production environments where you say it's not allowed to load a native agent. So you can use the things that are already active in the JVM and get useful data for that purpose. So that's one of the also common use cases. Really. So.
And what you're also supporting, because I tested this 1 year ago, is the custom events, right? So you can have your own business events, Java Flight Recorder events, and they will be correctly displayed in JProfiler, right? So
yeah, absolutely.
Yeah. You say absolutely, but this is not that well known to Java developers. And to tell you a story, I was asked to assess a private cloud architecture, and it was OpenShift based, so Kubernetes. And I usually spend time in public clouds. And if I go to public clouds, I try to get rid of the entire infrastructure, because this is why we have public clouds, and it's completely serverless. But serverless makes less sense in private clouds. So in private clouds, you can do the opposite. It's okay, what are the strengths of the private clouds and what we can do better than in the public cloud? And what you can do in your private cloud, which means you have on-premise, your OpenShift cluster, let's say, or Rancher or whatever, you have more control over the cloud. It is not serverless, so you can actually SSH to the machines if you like, or at least, reach the machines. And what we did then, we said, okay, then we will run JFR all the time in production, because we can absolutely do this, and this is a lot harder. As in serverless is impossible. And if you go Kubernetes to public cloud, what's the point? Because you pay more, and there's no advantage over your on-premise data center. And then, of course, something like JProfiler will shine, because if we have already JFR activated, just looking at garbage collector in memory is a little bit boring, or is not. We don't go far enough, and we can have a full observability by emitting our own business events. And what we talk about is, let's assume we are ordering a book or your JProfiler license, and if someone orders a license, we can emit an event, license ordered. And the interesting part in Java is that simple to emit such event. This is like an inner class with annotation. This is nothing. So for you it's clear, because you are working all the time. Yeah. If I show this to developers, they are stunned how easy it actually is. It is way easier than Prometheus, for instance. Way easier. So you need a less infrastructure, no micrometer, nothing. This is part of JDK, which is perfect because you don't have any external dependencies, right? So, and you only have to have your own custom events from the business perspective. Plus, JVM has already, I don't know how many, hundreds of built-in events, I guess. And then you can attach with JProfiler, and you get the complete observability about the stuff. You will see what's going on. You can have triggers on specific things. And what we talk about, you could have also triggers about business events, right? So you can say, if an order happens, something you can do, right?
Mm-hmm. Yeah, that's really, I think, the basic thing here, that JFR, you can run that in production all the time. And the profiler is not something you should run in production all the time. It's really something with a native agent that you should use if you have a real problem and think, I need to figure this out, because it introduces like overhead, it loads this library, changes the behavior of the GC of various things in the JVM. So that's something you do on a problem basis and not like on a daily basis.
And this is also problematic because it slows you down. You had a overhead at least more than 10%. So it really depends what you are doing. And you need, you have these specific ports, and this JFR is more or less built in. I mean, this is. And the overhead is low because this is the JVM gathers this events anyway, because it needs for internal optimization. So this is why it doesn't cost much to run JFR in production.
It's append only. It doesn't accumulate anything and so on. There is no bookkeeping. It just spits them out. But then, of course, the drawback is that you have sometimes not enough information, so that you get this information as it can be collected without a lot of overhead. And so this is basically the trade-off.
But the cool story is, let's imagine, this is what I advise to projects actually. You should start with it already during development time. And let's say we have some stress tests, right? So I would say, okay, there is we order 2 licenses per second, and see how memory and threading is doing. So we have the correlation and even causation. We say, okay, if something, if too much is going on, we get in one point of time out of memory error or whatever. And we have already some experience of the basic behavior of the system. And if you go in production, so we will see, okay, for instance, there are too many licenses bought. If there is no event, like no offers, nothing, maybe someone tries to hack us or something strange happens. And if there are no cells, is also a bad sign. So what it means is, alone from the business events, we have we get a feeling what's going on in the system, and then we can correlate the business events to JVM methods, performance, and latencies and all the stuff. And this is already golden, because I can actually activate the profiling anyway on top of that. But this is way better than Prometheus, because the Prometheus in all the metrics, this is nothing with Java. You have after the fact expose whatever, and we get all the metrics in real time without overhead, without scraping, without additional image, and we can very easily define our own business events which are emitted. And we can act on the events, right? So this is actually observability in real time. And Prometheus, it scrapes every minute, every 10 minutes. You have exposed all the metrics, and you expose everything via JSON. It's aggregated again. I mean, this is huge overhead for nothing. So if we are on private cloud and we have the control, and you are a Java shop, then we are talking. We can achieve a lot more without any external dependency or infrastructure. This is actually the cool in
that's a very good insight. Yeah, absolutely. Yeah, right. So
in a project, this was I explained it this way, and someone said, why no one told us that? It's like, I have no idea, because this is a part of JDK. Maybe it's forgotten, too old, or whatever. And this is actually the interesting part, is way underappreciated what JDK can do, out of the box. And it's somehow forgotten. Everyone assumes they have to go to Prometheus, to have metrics, and actually get a lot out of the box. And lots of my projects are how to call it, task forces. And why they happened? Because they are nothing. Basically, right? They hope that the system is working. They have a little bit of, Prometheus metrics and health checks, liveness, and readiness, but they have no idea what's going on. And with that, with minimum, of profiling, you would achieve a lot. So this is actually the message. And with JProfiler also look nice without Visual Studio Code. So this we'll talk about it soon. But you have a nice UI, and it could correlate, the business events with whatever you already have. This is actually the power that you have in one place, the very high level business domain events plus the low level, and the correlation. I think this is golden.
Absolutely. Yeah, that's it. You have the correlation between the low level and the high level. That's like also the main value proposition that you have with this development profiler thing. It really like helps you solve the harder problems where you need both. Just one or the other is not.
And you are not on podcast 1.5 years. It means now you are vacations all the time, nothing to do. So the next idea would be, if you have the context, right? So the business events and the low-level events, you have the entire context. And if you have the context, you can pass the context to LLM and ask, what do you think about this? And get even more insight, This will work because I experimented with that, even with Prometheus, and you get great insights, actually.
So this is my homework for the next podcast?
Yes, but it should be faster than 1 year. But this is actually, but this, what I thought, because if you have the context, I mean, what I did just for fun, right? So Prometheus, just application running production, so I get the basic metrics. And I gather the metrics and created a JSON, pass to LLM, and ask, when the server will die. And this LLM look at this and say, okay, from my perspective, at this point in time, I ask why, and there came the reasoning, which was plausible, and this was no effort. So this was for me maybe like 1 day fiddling, and it worked with Quarkus out of the box. And you have even more context information, and context is golden. Without context, forget it, right? Mm-hmm. And with that, and if you use Visual Studio Code, you even have the source code. So you can say, okay, this event happened, this Java event happened in this class, and this is too slow. What do you suggest? So you have the complete loop, and this would be actually also very interesting. And this works really unbelievably good. And if you have a stack trace, then we are golden. We have a stack trace, we have the event, we have the entire context, the entire history, plus the code. And if you would get, access to the Git history, then you even could know, okay, the last commit caused the problem, right? So this is maybe for the next year. Right, so we have to write it down. The next,
yeah, but like about things being like quick and so on. This is like also like with the VS Code integration. That was also something that you could think like they have integrations for all these IDEs, so they can make another one for VS Code. It shouldn't be a big deal anyway, and it kind of. Makes sense, like if you think about it, but then you find out like VS Code is not a Java IDE.
Yeah.
It runs on Node.js as a Node.js runtime, and then you say, so what? I mean, you have to like build the functionality in like the native environment anyway. There is some API that you have to hook into and listen for some things or intercept some things like a run configuration and so on, and add your stuff and then make a connection. You have to program that anyway. But like where we come from is that we have like for all the IDE integrations that we have done in the past, which is like NetBeans, Eclipse, IntelliJ, and then like some things we don't support anymore, like JDeveloper, or even other IDEs that are now obsolete, is that that we have like a common library on the client side, like client side would be the IDE that do all the things that are common to all the IDEs. You may now think this is probably not a lot of stuff, but it's still it's not a super huge project like this IDE integration. It's a small project in a sense, but it's also like difficult because you're working in a complex environment. You have to adjust to the characteristics of the IDE. They're all different and so on. And then you have to have like communication, which has to be safe, which has to be robust, reliable, and this is never an easy thing, even if it's this is not a super big tool. And there's like information that goes both ways. It's a bidirectional thing. There's data that has to be shipped in both ways and so on. So it's not as simple as it looks. And this core that we have on the client side for the IDE is actually sort of pretty sizable. And it was all originally in Java. And then we sometimes, some time ago, we converted that into Kotlin. So we had that in Kotlin. But in VS Code, we can't use any of that, like per se, because we would have to have that in TypeScript or in JavaScript or something that transpiles to JavaScript, and would have required that we do all of this from scratch. And that was, of course, something that you don't want to like implement something again from scratch. It's like when you have apps for Android and iOS and you say, oh, I have this app on iOS. Do I really want to re-implement everything on Android? No, you don't. I mean, this is terrible. So you always look for things like to unify it. And that was something that we were thinking about. And then we had all this experience with Kotlin Multiplatform, where you have like the...
Ingo, maybe for the listeners, before we did, why I suggested Visual Studio Code last time, because it is popular. But from developer perspective, I actually don't like it a lot because it's slow. So if you work with it, you really see, if you control space, it's a little bit of lag. And if you work with, I use NetBeans a lot, and fire up NetBeans recently, it is immediate. So it is, for the latency is way faster, interestingly, in NetBeans than Visual Studio Code. Mm. And their IDEs like Z, for instance, they are crazy fast on GPUs, but they are not that popular than Visual Studio Code. And Visual Studio Code is even worse. They use remoting, LSP, what you probably had to do, right? A language server protocol, I think is the name.
And they use LSP. Yeah.
So what you had to do is I guess remote procedure call between Visual Studio Code and your runtime, or similar stuff, because this the Visual Studio Code, all the integrations are with this LSP protocol. This is how it works. And the cool story is now Visual Studio Code is one thing, but you have integration to Cursor, which is Visual Studio Code based, and Cursor is the leading AI development right now. They are very popular, so it means Visual Studio Code, JProfiler runs in Cursor, which is incredible. This is crazy right now, right? So because everyone clones Visual Studio Code right now, and all the cool IDEs are VSC based, right? Sorry, I interrupted you with the Kotlin. But a little bit of context. So not like we really love Visual Studio Code, but it's very popular. And for instance, why I use it. For instance, sometimes I use serverless step functions, and there's a great editor with the entire integration in Visual Studio Code, right? So in NetBeans, they will never come to NetBeans, for instance. So or JSONata support and whatever. This is a lot of plugins and small things which are part of the Visual Studio Code ecosystem. This is like Eclipse 20 years ago, maybe, right?
Yeah. So that was the problem, that we didn't want to rewrite everything in TypeScript or something, and then we had the idea to just like move the Kotlin core that we had to Kotlin Multiplatform. And this is like, first seems like something you could like do quite quickly. So you have this Kotlin code, and you move it to something that's called Kotlin Common Code, where you don't use any JVM calls, but only stuff that is provided by this Kotlin Common universe, which is very little. You don't have a lot of that. You have libraries that you can then load, like for I/O, for example. So by default, you don't have I/O, but you have a library that then provides I/O and has support for all the supported backends, or for some libraries only have support for some supported backends, and so on. So you can do that, but it's like not so easy. First of all, threading, you have multi-threading in the JVM. That is very different in Kotlin. You have to use their coroutines. I mean, that's something that you, as a Kotlin developer, you also use like for server-side development and so on. But it requires a lot of work to move something from.
So what means for me sounds like you don't like Kotlin anymore, right? So you would.
No, it's just I just said it's a lot of work. So it was really, I spent a lot of time developing this VS Code integration, but it was very fun. It was really like one of the most fun things, the coolest things I did last year. Because I mean, it's like magical afterwards seeing your code running on the Node.js runtime, just like that, or having like these two backends where you can run the same code. Like I have these unit tests for the integration, for the communication, and I can run them like test JVM and test Node.js. And it uses the same code, and just once it runs on the JVM, once it runs on Node.js, and that's like sort of something that I'm always amazed about this when I do this. So that runs in our tests, in our JProfiler tests, that is now a standard part, that we have these Node.js things there. And yeah, otherwise, of course, you have to have this, like, you have to learn TypeScript, because there must be some layer where you interface with the IDE and use their API to do something. You don't have to go into the language server stuff, because like where we integrate is the user clicks on run something or debug something, and we intercept that, and then we add that's the main thing we do: add a VM parameter to the Java call. So that the profiling agent is loaded.
Mm-hmm. So you imported your Java runtime, which runs on clients, to Kotlin Multiplatform Common, right? In order to be transpiled, or how to call it, to be transpiled to JavaScript, right?
Or compiled. It's a transpiler, of course, because it's like TypeScript in a sense, where you have TypeScript, write TypeScript, and it produces JavaScript. Actually, the Kotlin Multiplatform thing can do WASM, it can do Node.js, and it can do browser.js. So it has these three things in the JS in the browser space, where it can compile to. And and then one fascinating thing also, that so one thing this strings along is that one thing I have to do in the IDE is to load class files, like the binary class files. And that is required because sometimes I get method signatures. Sometimes I get method signatures that I need to find a location for, and I can't match them because under some circumstances, like lambdas or something like that. And I need to open the class file and look for the line number. So I need to be able to read the binary class files. And this is something I do with a library that I developed. It's called JClassLib. It's actually more like the viewer, a bytecode viewer, where you can inspect all the properties of a compiled class file. But it's also a library to read and write class files. So
is it open source?
Yeah, that's open source. It's on GitHub.
Cool.
You look it up. It's JClassLib. It's under my name, Ingo Kegel, JClassLib.
And what JClassLib can do? You can write bytecode, read bytecode.
Yeah, but that's not. That's not the primary thing. The primary thing is that you can look at the class files. It's a visual display. You can also modify it. You can go and edit some strings in there, or edit some instructions. So you can tinker and hack with class files. It's actually quite popular. It has 3,000 stars on GitHub, so go check it out. So and that I need it on VS Code as well. So what I did then is that was actually surprisingly easy then to take the part of JClassLib that reads and writes class files and move that to Common Code, because there is not a lot of I/O that's very localized. And it's mostly about data structures and like normal in memory things. And that was quite easy to port. And so I made JClassLib, this part of JClassLib, I made it multi-platform. And so I used that in the VS Code integration as well, to read and write class files, to read class files there, to find line numbers for the source navigation integration. When you're in JProfiler and you tell the IDE, please locate this method or locate this class, so you can look at the source code when you have a performance problem, for example. That's one of the main things also that the IDE integration does, not only just starting it, but also interacting from JProfiler. Mm-hmm. So that was another thing that I did. And then, of course, it goes along and you try to make things better. And one of the things that I want to do with the IDE integrations is support as many different runtime configurations as possible. So you have to look at tests, how they are started. That's always this
was next question. Can I profile tests? Unit tests?
You can profile tests, and that's also something that you specifically have to support and think about and so on. That is included in the VS Code integration. But then also build systems like Gradle. Yeah, if you have a Gradle project, then often you run your stuff through Gradle tasks, because there's no real way to run it through the IDE. You have to have some pre-processing done by the build system to be able to run the application. So a lot of people start their run configurations through Gradle, and VS Code has a Gradle integration, which is actually maintained by Microsoft. It's in this default Java package that you install there. And they did not have like any API to add additional tool options like we would have to add. That they don't have that. They have their own debug thing where you say debug an application and then it adds the debug VM parameter, but there was no way to add our stuff. So I did like a pull request. I added this functionality to the Gradle add-on in VS Code, and they accepted it. And so now this is like part of the VS Code ecosystem that somebody can write a profiler, profiler integration that adds VM parameters, or some other tool integration that adds VM parameters when you run Gradle. When you run Gradle run configurations. And that's quite. I like that I'm responsible for that, and I also did that for incidentally for IntelliJ. They also had the same situation that didn't work, and I did a pull request, and now this is possible for all tools to do that. So that's, I think, shows like how open source really works. Yeah, if somebody does something they need, and it's like enriches the ecosystem for everybody.
Mm-hmm. So what you did, you and the JClassLib. Okay, JClassLib before was external projects which you pulled to external. So your dependency, but was maintained in a standalone project and was pulled into JProfiler, right? And what you had to do right now is just to pick the parts of JClassLib what you needed, subset because of the common limited Kotlin runtime, and you migrated parts of JClassLib to common runtime in order to make it available in Visual Studio Code, right?
Yeah, the JClassLib has modules, like sets this data module where you just writing class files, no UI, anything, just simple input output. And there is the bytecode viewer module, which contains most of the code, where it's a swing application where you look at the class file, move around, look at the code, edit stuff, and so on. So that those were already different modules. And I just made the data module multi-platform. So you don't have to do multi-platform in a Kotlin application for everything. You can also just make just one module multi-platform, and then that. They have actually a nice website, which is called klibs.io, where you can see all the multi-platform libraries that exist. And they automatically collect that from Maven Central, which I think is a neat thing, because like the multi-platform compiler adds certain metadata information that they then scrape from the Maven Central repository. And then they have all the libraries that are, and they rank them in a certain way, like GitHub stars or something, categorize them. And so you have this complete set of multi-platform libraries that can help you. I also use multi-platform libraries, found them there, like, for example, for starting processes. That's also something you don't have to, otherwise you would have to worry about how do I start a process in Node.js and consume, standard out, how do I do error handling. And so it's a complicated topic. But if you have a library that does that all for you, then you have one API and you use it, and then it works on the JVM, on Node.js, on iOS, and wherever. And that's something that's really neat, that they already have this search engine or page where you can find all these different multi-platform libraries. So that was a good experience.
For me, this is one of the first killer use cases for Kotlin, because what you did is you were able to port Java to Kotlin and then to TypeScript, and now you could even create a native Kotlin app CLI, right? Because now we have this or whatever.
Absolutely. Like if you look at the JClassLib example, you have this UI where you look at the class file, and that's a Swing application. Of course, there is no way to make the Swing application multi-platform, but in general, you could make a UI that is multi-platform. They have this compose multi-platform thing where you have the UI. Mainly, the idea is to have like iOS and Android, like a common UI, which is has one API and one way to do it, and then you have it on both platforms. But they also have this on desktop, on web. So it's on all the supported platforms. They have this UI. So there is a way to write native UI with Kotlin multiplatform with such a library. That would be possible. It's not in my interest to do that because this wouldn't really make any sense for me, but it's possible to do that.
What's maybe useful, but I had recently podcast with GraalVM team, and what they did, or what's already supported, you can run Wasm on Java. It means you could actually cross-compile your stuff to Wasm and then run in GraalVM, and just an idea. I don't know for what, but this is crazy that it actually works. And this is bidirectional, so you can compile Java to Wasm and Wasm to Java. It wouldn't help you, of course, because your libraries are too broad for Wasm. But if you have Wasm with Kotlin multiplatform, you could. I think it's called Wasm image, and this is like the native image from GraalVM, and you can run natively on Java. So this is the full circle. So maybe
this is really exciting. Like there's lots of stuff happening in Wasm at the moment. There's lots of development there,
and they also supporting the system interface from Wasm, so that you can also access file systems and so forth. And this is implemented in Java, and it's very secure because they intercept all the calls. So this is like the security manager, but even better, right?
A little bit like the JVM in a sense.
Yeah, exactly.
Wasm runtime.
This is actually an extremely cool project, right? So what you have right now, because of the Kotlin multi-platform, you can expand wherever, right? So you could have a web viewer, for instance, for whatever you like, with a little bit of effort.
You mean like with the IDE integrations?
No, not only Visual Studio Code. You could now port, your JClassLib or partial viewer for business events in web. It will be doable, right? Because you could have a web viewer which only displays in a web app, for instance, the business events.
Yeah, right. I mean, that's kind of the idea of all this multi-platform stuff, that you can really...
Yeah, but you got it now, right? So it was hardly possible before, but now it could be easier possible because you can extract just a viewer for business events or alert. It's like, okay, all alerts are displayed in this view, and you don't have to start JProfiler, which is native. It can be a web view or redirect this to whatever, to Kafka, whatever you like. So I mean, this is
And then you have you always need this lots of logic on the side where you display something, because you need like data structures and stuff like that, and you need to serialize them to the back end and so on, and so that's always there. Also like for a web application where you have something in the browser in the back end, and then you have all these data structures that you previously needed to duplicate. You have like classes that in the languages on the browser side and classes in the back end in Java or Kotlin. And if you have Kotlin multi-platform, you don't do that. You have just one code base, and you have like a serialization framework, which is Kotlin serialization, where you just transfer that. And we use that too. We have Kotlin serialization to transfer all the data from JProfiler to the IDE integration. And then once it comes out on the other side, it can be a JVM, can be a browser, can be Node.js, it could be a native client. So that makes it really flexible and keeps prevents you from duplicating any code. And that's really, really very powerful, because that's one of the worst things, if you have to duplicate entire sections of your code just because you're running somewhere where the language is different.
Now loosely related, because maybe another use case, because you said you had Gradle and of course Maven. So what I do, I run in Maven system tests, which are black box or end-to-end tests, all my projects. And would it be possible to use JProfiler, for instance, to break the test? So it's okay, the test, what has happened within the test, I expand 2 business events, and it shouldn't be slower than this. And you could measure the actual performance in the backend, not the test performance, because this is latency, whatever. And then if this is not met, then the test is red. This could also work, right? Whether now, I don't know, but it should be technically possible. Because right now,
port that back to the IDE to make the test red.
Not even IDE. So now I'm talking about something like Jenkins. I don't use Jenkins anymore, but code build, code pipeline, this we use all the time. And they are stress tests, and system tests and later stress tests. But the system tests, basically they call Quarkus remotely, and I expect behavior. So I have my asserts with assert J, I'm happy. But we can do more than that, right? Because, for instance, we could have performance regression test. So, okay, I expect that this is at least as fast, and but as fast is hard to measure from client, because everything can happen. Network can be slow, whatever. This is too much flakiness.
So but you with data from the remote side to analyze in your asserts, basically.
And I could have my system test, which is basically Visual Studio Code without Visual Studio Code. Is my it's just the minimal Kotlin runtime, whatever you have as an assert, and it will call out to the Quarkus which is running. So the Quarkus will be instrumented, right? And if the criteria is not met, you only have to break the test. So exception happens, I don't care. And then we could have automated tests with some more insight. For instance, I could say in this test, I expect 2 business events and 3 garbage collector events, whatever. You know what I mean?
And then, right, so you basically need an API on the other side to retrieve this information.
Yeah, this is almost the same like Visual Studio Code profiling, but in profiling, I only see what's going on inside. And during the system test, it could be even slower. I don't care then. But it will break my tests if the criteria is not met. I said, I would like to have at least 3 threads, right? So you have, for instance, I test parallelism, I do executor service, and there's 1 thread broken. If 100 threads also broken because I only have 2 CPUs, and I've expect, that the test will never consume more than 10 megs of RAM, and it consumes 20, also broken, right? So you could have,
yeah, right. That's an interesting idea to have like this runtime characteristics API where you could ask a lot of questions about what just happened, or reset it. Say, okay, now I'm doing something, and then I stopped doing it, and what happened in the meantime?
Yeah. For instance, I can give you 2 examples. What I did last year. One was S3 buckets for sure, right? It's like on AWS is like a binary storage, and whatever you do in the cloud is HTTP call. Right now we have the following situation. I'm in serverless environment, Lambda, and I'm running with 1 CPU. It means if I do the fork join framework or whatever, right, it only sees 1 CPU. But what I would like to do is I would like to set the common parallelism to 30, because then the HTTP client of S3 can parallelize the HTTP requests, and even have just still 1 CPU, but I'm faster because I don't have to wait for every request, right? And in this particular case, what I did, lots of logging. So does it actually work? Does the native S3 client from AWS start the 30 requests on only 5? What happens? And with your profiler, I could say, okay, I expect now 5 threads, which starts with AWS S3 or whatever. And if they are not 5 threads, the test is broken because there's no parallelism, right? So simple things like that. For instance, right? So I could have more insight for free.
That's actually quite an interesting idea. Huh? So as a starting point for further, you have to like pan this out and look at all the implications of it. But that's an interesting idea. We're thinking about things that we can do, and like also performance regression testing is also like a main topic that we're thinking about for future improvements. And that sort of kind of goes into the same direction, like having tests, performance tests, like how do you actually measure performance regressions? How do tests actually make, that's a very difficult topic. It's also something that's very difficult to do right, performance regression testing.
And the craziest idea, what I did, and that the biggest impact in management is cost savings. And the interesting part is, if you go to AWS cost calculator, so what I know is an S3 read costs that much, S3 put that much. Then I know we have 2 gigs of RAM for Lambda and 1 CPU, so I pay for 1 gigabyte second that much. And what I implemented, and dollar profiler. So I logged the dollars in production because I knew the formula, but what I had to do, right? I had to intercept the get calls and so, and this was very primitive, but it works quite well because if you think about this on serverless, you could do Kubernetes as well, but on serverless it's easy because there's only 1 thread. So what I basically had an atomic integer or atomic long and just counted everything up and then was able to estimate costs. But what you could do, right? For instance, the calculator AWS, recently there is an MCP server, so you can get actually the costs programmatically. So you can have, a RAF cost estimator, and you have cost regression, for instance. So you could estimate during tests how expensive will it be in the cloud, right? I do it all the time because we can have a huge cost savings with serverless, but only if the methods are executed quick and there's not too much traffic, right? So if you get thousands of requests per second for God serverless, so this is, you have to buy EC2 machine or Kubernetes. But for such cases, you have the complete insight. So you only have to know, which external APIs are called. I understood from you know it anyway, because your examples were Apache Kafka and Hibernate, and I would say S3 is even easier. On all the cloud APIs, just HTTP. So if you intercept it once, you only have to look for namespaces, because this S3 DynamoDB, this is for you nothing, right? You only need the table, and then you could have a nice cost estimator, rough, because performance is one thing. I got mostly hired because costs are too high, not necessarily is too slow. Clouds are a little bit slower, but if it gets too expensive, so we have to do something about this. So
it's actually a great idea, to have a cost view where you just
all my recent projects have cost view right now. No, this is primitive. I have in logs statements, you will say, okay, this call was this $, and management asked me to create a calculation, so I have to go to Excel, and do something for it. In one project, I forgot, to multiply per month. So, but it was my estimations are so high that it was still in range, but it is always a little bit dangerous. But I have to do it every project differently because different setups. But for you, it's nothing. So it is.
Yeah, that's right. Yeah, we could really do that. We have the HTTP client.
Yeah.
We support a long list of HTTP clients and intercept that and have the URLs, and we could actually really analyze that for what is it actually doing and how expensive could that be.
Yeah, and there is a project called, I think, Power on AWS, and what they do is there is interesting part. Just because I saw you have less to do on new business ideas, right? So the interesting part is what the project are doing. If you go with Java and Lambda, and they try to save money, right? Obviously, and what they do is, okay, I dedicate to Lambda 128 megs of RAM. The problem you get there is, with 10 gigs of RAM, you get 6 CPUs. With 128 of RAM, you get 1/11th of a CPU. And Java does not really well with 1/11th of a CPU. So it means now you are incredibly slow, and you are actually more expensive than with one CPU, because the Java is over proportionally slow with 1/10 of a CPU. And what stands out is that with one CPU and 2 gigs of RAM, you can actually save money, and you are faster because of one CPU and 2 gigs of RAM, right?
Mm-hmm.
And but what, for instance, what you could do, you also know in the test, okay, the Quarkus. I'm talking about speaking about Quarkus because it's incredibly fast startup times, and this is very suitable for serverless, right? Mm-hmm. This is only the reason. And with Quarkus in your test, you will see, okay, I only need 200 megs of RAM. And you could also see the parallelism, and it's okay, but still go with one CPU, whatever, and the data is out there. So like a small hint. And I think this is you have everything, right? So I had to really do it from logger perspective with interceptors, but for you, it's a piece of cake.
This is a really intriguing idea. Thank you. Never thought about that. That needs sort of the kind of real world experience where you're actually working with people who
and what really changed for me hugely since Corona, I don't know whether we talk about this in other podcasts, for sure, we start on an Excel sheet in every project. They ask me now, we have to go to cloud, what is the solution? And I say, okay, cost-driven development. We can do whatever we like. We have 300 APIs, but we have to pay for it. So we do Excel. After a few days of Excel, we know our cost model, and then we go for it. And sometimes the programming is uglier. Like S3 is no fun if you have a Postgres database, for instance. But it costs. So no kidding. On a conference, they run a company after refactoring. I think I asked them that they have the entire department for €50 a month. And before, it was several thousand euros with Kubernetes clusters or whatever. This is a huge, huge amount of money you can actually save. And this is why I still do Java. But cool story is Java is number 4 from performance perspective. So it is really fast.
Yeah.
And with a little bit of insight and regressions, we are absolutely in. But this is not that known, interestingly. People are assuming Java is slow, but it is the opposite is true.
No, it's the opposite.
Yeah. Okay, this was just a brief.
So thank you. Got to charge me for that.
I will buy the next license anyway. So this is my. And welcome back, and we can talk about this because interesting topic. But what I wanted to ask you, what are now? I will have to reinvite you back anyway because of JClassLib. So this interests me, So we can talk about this and a little bit more about Visual Studio Code. But JClassLib is intriguing, so I'm just thinking about this right now. But what are the features of Visual Studio Code the listeners get? Because this is a nice chat between us, but someone will buy the product to do something with it. So for me, was the most important thing were unit tests. Because less so now that I have to profile application, but this is really interesting. If I build something, I write simple code, they can run unit tests, and see whether it's faster or not faster. This is for me a huge thing, because sometimes, if I write simple code, there are lots of developers say, okay, what you should do for loop and not a stream. And I say, okay, I don't care. If this looks nicer, I start with a stream. And if you have a problem, we do a for loop. But with your JProfiler, I don't have to argue. I will show, okay, my stream takes 2 milliseconds and the for loop 1 millisecond is not worth of optimizing. I go with a stream, right? Mm-hmm. So this would be a perfectly doable in Visual Studio Code, right? I could have my unit tests, which acts as a business method, and I will see whether a stream or for loop is faster or not faster, right?
Absolutely, yeah.
This is huge already. So less discussions in my projects.
It's absolutely something that you should do to see these kind of things. It's really nicely isolated in a unit test, much better than in profiling the whole application, where it's difficult to assess.
And it looks like run with JProfiler on unit test, and we'll launch the unit test with the JProfiler.
Yeah, I mean, the VS Code, every IDE has its own idiosyncrasies, and in Visual Studio Code, it's not possible to contribute something to the framework like profile an action that then profiles that the way we have it like in Eclipse or IntelliJ, where we can like modify the menus in that way. So that's not how VS Code works, and they don't want that, and they don't have like this kind of thing. And so in VS Code, it's a toggle where you have a combination, a key combination. You can look that up, of course, in the action panel, and it's about toggling between running normally or running with a profiler. So you kind of switch on profiling, and then it doesn't matter if you debug the main application, or if you run a unit test, it will add the profiler to it, and then you can toggle it off if you don't want to profile and run normally. So that's the same thing like for the Gradle integration. When you run the Gradle task, there won't be like a run with JProfiler. It will just be run it or debug it. But if you have profiling toggled on, then it will profile it. And JProfiler will start up in parallel. So JProfiler is always like this separate application, and then they talk to each other. JProfiler and
but this is always the case, right? Even if you compile Java, that the language server runs behind the scenes, you see this because if you say kill all Java, Visual Studio Code is not operational, and then they restart Java behind the scenes, right? And then you can do. This is always what takes. If you start a project without JProfiler, it takes a while until it knows everything because the Java language server is started. And and then Visual Studio Code just talks to the Java language server, right? This is what's
going on. It does that in this lazy way, so it starts it quickly, and then.
So I get an action. This is Shift Command P, I think, and then I can.
Shift Command P, and then you do JProfiler. You search for it, and it says start profile with JProfiler, and you can toggle that.
But I can have individual tests as well. So to start, or the entire class.
Well, you just start your test like you started normally in the test explorer.
Okay. So I can have my run action with test, but in this particular case, I can toggle the JProfiler runs in addition to that. So right?
Yes.
This is cool. Okay,
that's the way it works. And you, of course, also have the attach functionality where you say it's already running. That's also like for unsupported run configuration types. There's always like some. For example, if you start something with Maven, with Maven, unfortunately, in VS Code, there is no. They also don't have debugging. Like there is no way to start something in Maven and debug it in VS Code with the UI. So there is also we couldn't do that. Once they add debugging, we can then like try to do profiling. But then you would have, if it's only startable through Maven from VS Code, then you would have to do that and then say attach to the process. But from within the IDE, like there is this attach button, because then you will have source code navigation in JProfiler back into the IDE, even though you didn't really start it with JProfiler from the IDE. So that's the alternative always, to say attach to something, but give me the source code navigation in the IDE. Also, like if you have snapshots, that's also something common. You recorded a snapshot somewhere, could be an HProf snapshot, could be a JProfiler snapshot, could be a JFR snapshot, and you can open that in the IDE. You say file open, and then you open that file, and then it will, because we have the file associations there, it will start JProfiler and set up source code navigation into VS Code. And you can then in JProfiler, you see some hotspot, you say, okay, where is that F4? And you go to it, and we have this cooperative window switching. So there is no this pain of like having flashing windows in the taskbar and it doesn't come up to the top. We have that implemented so that VS Code and JProfiler can reliably switch their windows.
Oh, this is cool. Like, it can have a multi-monitor setup and have JProfiler and Visual Studio Code, for instance, right?
Right. I mean, if you have multi-monitor, then it's already like not overlapping. Problem is always if you have this overlapping windows, and like you have JProfiler in the front, and then you say you see some method and say I want to see the source code there, and then you say F4 or like from the context menu show source, and then JProfiler tells VS Code to come up to the front. And usually, if you do things like that, that doesn't work because operating systems don't like window focus stealing and so on. They would at maximum like flash something in the taskbar and say, okay, this application is seeking attention and wants to come to the top. But if you have native code on both sides, you can do cooperative window switching and use special APIs to allow that. And we have done that for all our integrations, so that this like becomes a seamless transition. It doesn't feel clunky to work with two processes.
Yeah, but I have the same problem with multi-monitors because the JProfiler will be hidden by another Visual Studio Code, because how I work with Visual Studio Code, I have multiple workspaces open at the same time. So multiple Visual Studio Code windows, which are independent from each other. Old projects, several projects, context and documentation, whatever. And and the cool story is what I understood is if I have on the left, my main project, on the right is JProfiler with all other context. So if we'll do F4, it will just come to foreground with JProfiler, right?
Yes.
This is the killer feature for me. And I'm sometimes working with one window, of course, Airplane or whatever, but usually have multiple monitors. So it means you have the entire UI is JProfiler as it was, and the Visual Studio Code is more or less like an agent, right? So it communicates with the JProfiler.
That's right. So like implementing the whole profiler in the IDE, that would be like terrible and would really not work. We did that once in NetBeans, like at the very beginning. We had this idea that we would have the JProfiler UI directly in the IDE. And we had that in NetBeans, and it was not a good idea. It's also not a good idea to bring so much memory usage into the IDE. That's super unpredictable, because the profiler potentially really needs a lot of memory. Like think if you open like a multi-gigabyte memory snapshot, of course the profiler needs a lot of memory to do that. You cannot bring that into the memory space of an IDE where this is carefully selected what the IDE needs. So this really has to be a separate process in that case. It's not just a simple viewer. It does a lot of work.
But I think so minimal hints, right? So what I could do, I can imagine I'm working on a unit test and try to make it faster, and it all will display faster, slower, a little hints, not the IDE, you are right. So because your IDE is pretty sophisticated,
Well,
having this
in the IntelliJ, that's something we don't have yet in VS Code. In IntelliJ, we have integration into the gutters, where you, after you profile, you see these arrows, incoming and outgoing.
Mhm.
So for every method definition, you see that in the gutter, and you can click on it, and you get like a drop-down menu with a graph of all the methods that either were called or where you have been called from, with all the times, and you can click on those to navigate to them or to navigate into JProfiler to do further analysis. So that's something that we have for IntelliJ. We're looking at options to do that in Visual Code.
Yeah, because Visual Code, if you run the test, you see already from test perspective the performance. And if you add just more numbers, right? So you could say this was the memory, whatever. So just a little hints, you show my added value and see, what happens. Because if you add too much, then I will switch to IDE. But the high level information would be probably cool. And what I think which is interesting, 10 last runs, right? So if a small graph or whatever, so if I run my test and change code, run test, change code, see is it actually faster, is it slower, right? This would be interesting to see variations. And for instance, cursor is AI agent. So what you do is works actually well. Or Claude Code is what Claude Code is not Visual Studio Code, but it's Node.js actually. So this is no problem for you. What they are, you can write Java code with prompts, and this sounds strange, but it works way better than assumed. Especially if you have your own rules, it is crazy how good it works if you know what you are doing and you are very strict with prompting. But so what I for instance did for fun, I have small builder is called Zibi. It is just based on Java C and nothing else. So Java SE without any external dependencies and builds incredibly fast, and it's a shell script. And if the build breaks, it is just -1. So and I played with the agents, and I say, okay, just use this for compiling. And if the script broke, they fixed it. So they didn't care whether it's Maven or not. It was my zb.shell, and it also worked. And where I'm going with it is, if you provide, for instance, additional information, more memory or less memory, you can tell the agent, do whatever you like, but the memory footprint must not increase. And the agent will try as long to modify the code, as long the code is faster than assumed, So with just feedback, are you actually faster or slower? Are you consuming more memory and less memory? With these two things, it will also incredible added value. And more context, I don't even know whether it's needed, because the LLMs don't care. They need just the two numbers, and you are basically done. And because I'm thinking more and more about agents. So, for instance, what I do right now, I spend lots of my time with Java and all the stuff, and there are lots of projects out there which looks like what I did the last 20 years or even longer. Boundary control entity, business packages, package info, and the entire structure. And I've wrote 2,000 posts. I check it out on my blog about that. And what's coolest, everything is now in LLMs. So I try that, and they know how I'm thinking because they read everything, and there's lots of information out there, and all the source. And if you think about this, my world, like microprofile, Java E, all these specs, they were open. This was open PDFs, and everything was scanned by LLMs. It means they exactly know how we wrote the code 20 years ago. It means what happens right now is the code I wrote and what LLMs are writing right now is almost identical. So we have actually the standards paid out after all these years because LLMs just read the standards. And I give you an example. I like Quarkus, but if you go to Quarkus documentation, you will find all the possibilities what you can actually do. You can do reactive, non-reactive. You can do this client and not this client. And if LLM reads that, it's a little bit confused because you get all the possibilities and you have exactly know what they are doing. But if you go to the agent and say, whatever you do, it should be microprofile in Jakarta E. There's only one way. Mm-hmm. And then with Quarkus, and you get always consistent code. And what I'm also doing right now, I'm writing rules. If I see something, it's like, hey, never do this, do it this way. And I have hundreds of rules already, and I try to one day I will publish everything if it works well enough. But having this, you get code, we get assertions for agentic workflows, and with your JProfiler, we get the context with runtime. And then we can say, hey, LLM test must not break, and it should be faster. And then there's an MCP, which is very easy to implement. I even implemented one recently. You can have the code is no dependency ZMCP on my GitHub account, and you can plug JProfiler to this, and it will only report, the memory consumption and, for instance, threads. I think memory or just memory and speed and performance is actually good enough. I would give you the method name, and you give me the performance, for instance. Very, very basic. And LLM will optimize the code as long the criteria is met, for instance.
Yeah, that is also like a topic that we're thinking about a lot recently. Also for our next version of JProfiler, that's like how can we help agents optimize for performance, and that's very good input as well from your perspective. So thank you for that. It's a very productive discussion for me.
Yeah, for me as well, because I get also the more ideas if I talk with you, because with the Kotlin multiplatform was cool because you can think further, and you mentioned context several times. It's actually cool because it's also what you need to know in LLMs with the context, and a recent podcast was about Brock KK.ai. A really nice guy, Jonathan Ellis. He created actually one of the Cassandra committers, the database, and JVector embedded. And he implemented an agentic AI. It's crazy, Brock AI with Swing, because it was faster, complete in Java, and it's open source. And I think you can very easily plug JProfiler there. And listen to this, Jonathan Ellis. Just ping him. He's spiced on Twitter. And because he already does that, so he has the agent. This is architect mode, and he can evaluate criteria, and this as long as this criteria is met. And JProfiler would be great because you can say in JProfiler, just tell me is it faster or not faster, and the agent will proceed until the goal is met actually. And it is Brock with K.ai. It is open source completely, and you can. This is a startup right now, and great ideas, but this guy has a huge experience with Cassandra AI and JVector databases. He implements for years. He was DataStax, and now he created a startup, Brock AI. And I tested this, and it's really, really interesting. Because what he does, just for you, if he sees a Java project, he looks at Maven dependencies, it decompiles all dependencies, creates method stubs, and passes everything on LLM as a context. So this is no other tools are able to do that because he understands the entire Java code. And so this is actually a unique perspective for Java developers. And for you, because it's Swing, maybe you offer MCP and you are done, but there's a small...
That's very good information also. Yeah, I'll have a look at that.
Yeah, this was last podcast. And I think the very recent one, I think even, I have lots of podcasts in the queue, but this is about, it was called... there are too many podcasts. AI driven. Yeah, this was the last one, LLM driven development. And this was the second one, and it was about Brock Advanced, and the first one, how he created Brock. And it is complete in Swing, and it's like, why Swing? Because it's crazy fast. So the entire, you won't notice that it's Swing. It is installed with JBank, and it's open source.
Oh, yeah. Okay.
Yeah. Perfect. I think we covered, right? Visual Studio Code a bit.
We did that, yeah. The VS Code and the profile thing. I think we talked about that very well. Yes.
Perfect. And you are invited back very soon, JClassLib. So I will look at it, and then we can cover whatever we not covered. Really interesting Java world right now, happens a lot, and really, really exciting. And everyone was concerned, with what happens with us. But I think if you know what they are doing with LLMs, this is like productivity on steroids. And the interesting part is we have to be. This is also what I see right now with the LLMs and AI is if you don't know what you are doing after 3 iterations, you are completely lost, because LLM will generate so much code which looks good, but no one knows whether it works. But if I know able to read code quickly, and your your prompts are short and you know which direction you are going, then you are productive. But you have to be really, really focused. And you are productive if the code is simple, right? So, and for instance, if you write simple code, but it must not be slower. With JProfiler, I have my assertions and I say, go ahead, and it won't be slower automatically. And this is actually the entire automation is cool, because right now I had to do it by hand, right? I had my loggers, I had to unit tests, we had performance tests, but it was, you had to do this. And companies were not really interested in it, because truth is, all managers would like to have code coverage. Now, if they're 80% code coverage, everyone is happy, but the project doesn't even work, right? So right now it changes a little bit, but this was the sad story, at least in European projects.
Yeah, we are all getting our bearings with AI and so on, and learning how to do that in a productive way. You can do AI in a way that makes you slower, and you have to really know what you're doing. So it actually makes you faster.
Thank you a lot.
Okay.
Where people can find you? JProfiler on the internet, and
yes, and I hope you like our current website better than last time, because last time you said our website is so ugly.
No, I really like the Jolt Award. This was nice, as I remember. EJ Technologies, right? Yeah, this looks nice, fresh. It looks almost like JProfiler.
Node switch, So it is modern, and
ej-technologies.com is the website.
Yeah, that's it. Yeah,
cool. And how can people find you on social media? Are you on LinkedIn, on Twitter?
I'm on all the It's actually, if you go to the blog, you have all the subscription icons there, and that's all me basically.
Exactly. You are everywhere. Perfect. Thank you a lot.
Thank you, Adam. It's always great to be on your podcast, and I'm looking forward to